Hi everyone, welcome to today's GCSE Higher Revision video. There's 37 days to go to your GCSE Maths exam, and today we're going to be focusing on the topic of the nth term. And we're going to focus on linear sequences today, so we're going to look at finding the nth term of linear sequences. Tomorrow we'll be looking at quadratic sequences, so that'll be quite a useful one if you're aiming for those top grades, how to find the nth term of a quadratic sequence. Today we're going to be focusing on the nth term of a linear sequence. It's still an important topic because you might be given patterns and diagrams and stuff like that. You might need to find out how many squares are in pattern n and so on. So the nth term is quite a useful topic, and in this video I'm going to go through how to do it. I'm going to give you some questions to try yourself as well, so remember to press pause and try those questions. So let's get started.
Hi, today we're going to be looking at the nth term of linear sequences. So let's start off by looking at how to find the nth term of a linear sequence. So I'm going to do the first one here, and then there's one here for you to try, but feel free to try this one if you want to. So press pause and then press play in a second, and I'll go through it. Okay, so if I wanted to find the nth term of this linear sequence, well, I'll look at it and see what the sequence is getting bigger by each time. So to get from 7 to 11, we add 4, we add 4, we add 4. So it's getting bigger by 4 each time. So let's write down the multiples of 4 beneath the sequence. So 4, 8, 12, and 16. And they're the multiples of 4, and we call them 4n. And so 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on. So that's 4m. Now, our sequence was 7, 11, 15, 19. Now, to get from 4 to 7, we add 3. To get from 8 to 11, we add 3. To get from 12 to 15, we add 3. To get from 16 to 19, we add 3. So the nth term of the sequence would be 4n plus 3. So that's the nth term of that sequence, 4n plus 3. And if you got that, well done. Okay, now here's one for you to try. Here's the sequence 1, 8, 15, 22. Can you press pause and find the nth term of that sequence? Okay, the terms in the sequence are getting bigger by 7 each time, so we're going to write 7, 14, 21, and 28 beneath the sequence, and that's 7n, the multiples of 7. Now to get from 7 to 1, we take away 6. To get from 14 to 8, we take away 6. To get from 21 to 15, we take away 6. To get from 28 to 22, we take away 6. So the nth term of this sequence would be 7n, take away 6, and that's it. And if you got that, well done. Okay, let's have a look at some more sequences. So we've got the sequence 40, 31, 22, and 13, and so on. And then we've got the sequence minus 4, minus 1, 2, 5, and so on. Can you press pause now and find the nth term of both of these sequences? Okay, so in terms of the first sequence, well, we're going from 40 down to 31, so we're going down 9, going down 9, going down 9. So let's write down minus 9n, so minus 9n, which would be minus 9, minus 18, minus 27, minus 36. So the multiples of 9, but negative multiples of 9. So we've got minus 9n. Now to get from minus 9 to 40, we add 49. To get from minus 18 to 31, we add 49. To get from minus 27 to 22, we add 49. To get from minus 36 to 13, we add 49. So our nth term will be minus 9n plus 49. And that's it. Now, in terms of this one, you could turn it around and write 49 minus 9n, depending which way you want to write it. So you could write that, or you could write that. It's up to you. Okay, so that's the nth term, and if you got that, well done. Okay, our next sequence goes negative 4, negative 1, 2, 5, and so on. So we're going up 3, up 3, up 3, and so on. So let's write our multiples of 3. So 3, 6, 9, 12, and that's 3n. To get from 3 to minus 4, we take away 7. To get from 6 to minus 1, we take away 7. From 9 to 2, we take away 7, and so on. So it's going to be 3n minus 7. And if you got that, well done. Okay, let's have a look at our next question. Okay, now sometimes we might be asked to use the nth term to find perhaps the 50th term or the 100th term and so on. So we've got the sequence 8, 14, 20, 26, and I want to find the 50th term of the sequence. So feel free to press pause now and find the nth term of this sequence and then to use it to find the 50th term. Okay, so in terms of the nth term, we're going up by 6, going up 6, up 6. So 6, 12, 18, 24, and that's 6n. Now to get from 6 to 8, we add 2. To get from 12 to 14, we add 2, and so on. So the nth term of this sequence, 8, 14, 20, and 26 would be 6n plus 2. That's the nth term of the sequence. Now we want the 50th term. So we're going to do 6 times 50 plus 2. So we're going to do 6 multiplied by 50 and then plus 2. 6 times 50 is 300. Plus 2, and 300 plus 2 is 302. And if you got that, well done. Okay, let's have a look at another one. Okay, this time we've got the sequence 7.5, 9, 10.5, 12, and so on. And I want to find the 100th term of the sequence. So feel free to press pause now and find the 100th term of the sequence. Okay, so in terms of the sequence, it's gone up by 1.5 each time. So we're going up 1.5, going up 1.5, going up 1.5, and so on. So we've got 1.5, and then 3, 4.5, 6, and so on, got up from 1.5s. So that's 1.5n. Now to get from 1.5 to 7.5, we add 6. To get from 3 to 9, we add 6. To get from 4.5 to 10.5, we add 6, and so on. So the nth term of this sequence is 1.5n plus 6. Now we want the 100th term, so we're going to do 1.5 times 100 plus 6. So we're going to do 1.5 times 100 plus 6. So 1.5 times 100, that'll be 150 plus 6, and 150 plus 6 is 156. And if you got that, well done. Okay, let's have a look at another question. Okay, so this time we've been given the nth term of a sequence, which is 8n subtract 7, and we've been asked to find the first 4 terms of the sequence. So to find the first 4 terms of the sequence, we just need to let n equal 1, 2, 3, and 4. So if n's equal to 1, we're going to do 8 times 1, and 8 times 1 is equal to 8, take away 7 will be 1. If n's equal to 2, we're going to do 8 times 2, which is 16, take away 7, which should be equal to 9. If n's equal to 3, we're going to do 8 times 3, which is 24, take away 7, which would be equal to 17. And finally, if n's equal to 4, 8 times 4 is equal to 32, take away 7, which would be 25. And that's it, that's the first 4 terms of the sequence. And we can just check it because it's 8n, we're going up by 8 each time, so add 8, add 8, add 8, that's right. Okay, let's have a look at our next one. So this time we've got the sequence 19n plus 5, so feel free to press pause now and find the first 4 terms of the sequence. Okay, so if n's equal to 1, we're going to do 19 times 1, which is 19, plus 5 is 24. If n's equal to 2, we're going to do 19 times 2 is equal to 38, plus 5 will be equal to 43. Next, if n's equal to 3, we're going to do 19 times 3, which is equal to 57, plus 5, which would be equal to 62. And then finally, if n's equal to 4, and then 19 times 4 is equal to 76, plus 5 would be equal to 81. So the first 4 terms of that sequence would be 24, 43, 62, and 81. And if you got those, well done. Okay, let's look at our next question. Okay, let's have a look at our next question. So this time we've been given the nth term of a sequence, which is 4n plus 7. And we've been asked which term of the sequence is equal to 95. So feel free to press pause now to work this out. Okay, so to find out which term of the sequence is equal to 95, we're just going to write the nth term equals 95. And then if we solve this equation, we can find n, and that'll tell us which term of the sequence is equal to 95. So if we solve this equation, so we want to get the n on its own, so let's take away 7 and take away 7. So we're going to get the 4n equals, and then 95 take away 7 will be 88. And then if we divide by 4 and divide by 4, we get that n is equal to 22. So the 22nd term of the sequence is equal to 95. And if you got that, well done. Okay, let's have a look at another one. So there's another one for you to try. So press pause now and work out this question. Okay, so we're told the nth term of the sequence is 12n minus 40, and we want to find which term of the sequence is equal to 68. So we're going to write 12n minus 40 equals 68. And then if we solve this equation, we can find out n, which term in the sequence would be equal to 68. So let's add 40 and add 40. So we're going to get that 12n is equal to 108. And then divide by 12 and divide by 12, and we get that n is equal to 9. So the 9th term of the sequence is equal to 68. Okay, now sometimes you might be asked, is a particular number a term in a sequence? So we've got the sequence 14, 22, 30, 38, and so on. And we're asked here, is 426 a term in the sequence? Now, if they asked me if 427 was a term in the sequence, I'd be able to spot straight away and say, no, it's not straight away, because all the terms in the sequence are even. We've got 14, 22, 30, 38, and so on. So if they asked you perhaps was an odd number a term in the sequence, you could just say no straight away, no, it's odd. But in this question, we're asked, is 426 a term in the sequence? Now it might be, but now if we look at it, not every even number is a term in the sequence, so we need to find out, is this a term in the sequence? So what I want you to do now is I want you to think how you would do that. So press pause now and think, can you work out, is 426 a term in the sequence? Okay, so what we're going to do is we're going to find the nth term to begin with. So we've got 14, 22, 30, 38. And let's find the nth term. Well, we're going up by 8 each time. So it's going to be 8, 16, 24, and 32. That's 8n, the multiples of 8. To get from 8 to 14, we add 6. To get from 16 to 22, we add 6, add 6, add 6. So the nth term of the sequence is 8n plus 6. Now, is 426 a term in that sequence? Well, if we put this equal to 426, so if we write 8n plus 6, so we've got the nth term is 8n plus 6, that's the nth term. If we then put that equal to 426, if we can solve this and get n's a particular number, just like the last questions, we'll know which term in the sequence would be equal to 426. But if whenever you solve this equation you get a decimal number for n, that means that it's not a term in the sequence, because if it's a term in the sequence, n has to be a whole number. So if it's decimal, it's not in the sequence. If it's a whole number, it is. So let's solve it and see. So let's take away 6 and take away 6. So we're going to get that 8n is equal to 426, take away 6 would be 420. And then divide by 8 and divide by 8, and let's see what we get. So n would be equal to 420 divided by 8 is equal to 52.5, 52.5. So that means that 426 would be in between the 52nd term and the 53rd term. So is it a term in the sequence? No. And if you're asked to explain that, I would just say that 426 is in between the 52nd term and the 53rd term. And that's it. And if you got that, well done. Okay, let's have a look at our next question. Now, sometimes you might encounter patterns. So here we've got a pattern of discs. So we've got some circular discs. So we've got pattern 1 that looks like this, then pattern 2 and pattern 3. And the question says, find an expression in terms of n for the number of discs in pattern n. Okay, and feel free to press pause now to work out this question. So because it's pattern n, we want to find the nth term. So let's find out how many discs are in each of these patterns. So pattern 1, 1, 2, 3, 4, 5. There's 5 circular discs in pattern 1. In pattern 2, there's 1, 2, 3, 4, 5, 6, 7, 8, and 9. In pattern 3, there's 6, 12, 13, so it's 13. So we've got the sequence 5, 9, 13. Every single time we're just adding on 2 discs on the top and 2 discs on the bottom. So every single time we're adding 4 more discs on. So in terms of the sequence, it's 5, 9, 13, it would then be 17 and so on. We want the number of discs in pattern n. So what we're going to do is we're going to find the nth term. So because we're going up in 4s, we're going to write 4, 8, 12, and that's 4n, the multiples of 4. And to get from 4 to 5, we add 1. To get from 8 to 9, we add 1. To get from 12 to 13, we add 1. So it's going to be 4n add 1. So the nth term is 4n plus 1. So that means in pattern n, it'll be 4n plus 1. In other words, 4 times the pattern number plus 1. And let's just check that. 4 times 3 is 12, plus 1 is 13. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4, plus 1 is 5, and so on. So the number of discs in pattern n would be 4n plus 1. And that's great because if they say pattern 100, I could say 4 times 100 is 400, plus 1 is 401, and so on. Okay, next we're asked, can J make a pattern with exactly 251 discs? So in other words, can he make a pattern that's exactly 251 circles or discs in it? So feel free to press pause now to work this out. Okay, well, we know the nth term is 4n plus 1. That's the number of discs in pattern n. So if 251 is a term in the sequence, so in other words, if he can make a pattern with exactly 251 discs, then we can put it equal to 251. And if we can solve this and get a whole number, then it is a pattern number. If it's a decimal number, then no, this isn't a term in the sequence. So let's take away 1 and take away 1. So we get that 4n equals 250. And if we divide by 4 and divide by 4, we get that n is equal to 62.5. So that means that J can't make a pattern with exactly 251 discs, because that means that the 62nd pattern would have under 251 and the 63rd pattern would have above 251. So he can't make a pattern with exactly 251. So the answer is no, he cannot. No. Okay, let's have a look at our last question. So we've got this pattern of yellow and blue squares. So here we've got some blue squares in the middle and then some yellow ones above and below. Here we've got some blue squares in the middle and some yellow ones above and below. And again, we've got some blue squares in the middle and some yellow ones above and below. And we've got pattern 1, pattern 2, and pattern 3. And if we look below, we've got some statements. We've got statement A, B, C, D, E, F. And we've been asked which of the statements below are true. So feel free to press pause now and work out which of these statements are true. Okay, so statement A says pattern 20 has got 23 blue squares. So let's focus on the blue squares to begin with. So we go to blue ink and we consider the blue squares. We've got 4 blue squares in the first one. Then we've got 5. Then we've got 6. So in pattern N, let's work out how many that would be. So we've got 4, 5, and 6. We're going up in ones each time, so it's going to be 1, 2, 3. Now we could write 1n. I'm just going to write n, but instead of writing 1n, I'm going to write n. And then we would add 3, add 3, add 3. So the number of blues in pattern N would be n plus 3. So that means that if we wanted to find out how many blues are in pattern 20, we would do 20 plus 3, and 20 plus 3 is equal to 23. So that's true. So that's true. So yes, that one's true. Okay, next one. B. B says the number of blue squares is always even. Well, if we look at it, we've got 4, 5, 6, 5. That's odd, so no, that's false. Okay, next question. Okay, our next part C, says pattern 12 has got 62 squares in total. Now, we've got the blue. We could actually work out how many blues would be in pattern 12, because to find the number of blues in a pattern, we just add 3. So that means there'd be 15 blues in pattern 12. So in pattern 12, there'd be 15 blues. But let's consider the yellows. Now, I'm not going to write in yellow ink because it's just it's a bit light to see. So if I write yellow here, and then let's find the nth term for the yellow squares. So we've got 1, 2, 3, 4. So we've got 4 there. We've got 4, 8 there. We've got 12 there. So let's find the nth term there. So we've got 4, 8, 12. So we're actually going up in 4s each time. So you are going up in 4s. So that'd just be 4n. So the number of yellows in pattern n is just 4n. So we want to find out, is there 62 squares in pattern 12? So 4 times 12 will be equal to 48. So pattern number 12 would have 48 yellows, and it would have 12 plus 3 is equal to 15 blues. So we've got 15 blues and 48 yellows. And if we add them together, we can see how many squares are in total. 15 plus 48 is 63, not 62, so that's false. Okay, next one, D says every pattern has more yellow than blue squares. Well, actually, if we have a look at the first one, there's not more yellow than blues in the first, so that's going to be false. Okay, next one, E, says pattern 15 has got 60 yellow squares. So remember, the number of yellows is 4n, so 4 times the pattern number. So 4 times 15 is equal to 60. And we're told that means that the 15th pattern would have 60 yellows. And part E says pattern 15 has got 60 yellows. That would be true. And then finally, statement F says the number of blues in pattern 26 is a prime number. So remember, to find the number of blues in a pattern, we just take the pattern number and add 3. So we're going to do 26 plus 3 is equal to 29. And then is 29 a prime number? It is. So the true statements are A, E, and F. And if you got those, well done.
And that's it. So in this video, we've looked at how to find the nth term of linear sequences. We've looked at maybe how to find out if a term's in a sequence. We've looked at how to find maybe the 20th term or the 100th term rather than carrying on the sequence. We've also looked at how to use that whenever you're dealing with patterns and diagrams and things like that. So I really hope you found this video useful. Keep up the hard work. You're doing really, really well. If you found this video useful, please like and subscribe to the YouTube channel. If you know anyone that might find these videos useful, please recommend them to them as well. If they've been watching them like you, fantastic. But if not, and they're just finding out about it from you, they've got maybe 60 odd videos they can watch and sort of enjoy. I hope you found this video useful. If you have found it useful, please like and subscribe to the YouTube channel. And I'll see you tomorrow at 3 o'clock for the next video. Cheers. Bye.